Download this code from codegive.com, link in the description below. OK, let's dive into a comprehensive tutorial on analyzing code with Windbg. This will be a detailed journey, covering setup, basic commands, advanced techniques, and practical examples. Introduction to Windbg. Windbg is a powerful, versatile debugger for the Windows operating system. It's used to analyze both user mode and kernel mode code, examine memory, track down crashes, and understand the internal workings of Windows. While it has a somewhat dated interface, its command line driven nature allows for a high degree of control and automation, making it invaluable for developers, reverse engineers, and system administrators. Key features: user mode and kernel mode debugging. Analyze applications, services, device drivers, and the OS itself. Symbol support. Uses symbol files, PDBs, to provide meaningful names for functions, variables, and types, making code easier to understand. Memory examination. Inspect memory regions, view data structures, and identify memory leaks or corruption. Breakpoints. Set breakpoints to halt execution at specific locations and examine the program's state. Conditional breakpoints. Set breakpoints that trigger only when specific conditions are met. Stack trace analysis. Examine the call stack to understand the sequence of function calls that led to the current point in the program. Assembly code inspection. Disassemble code to view the underlying assembly instructions. Remote debugging. Debug processes running on other machines. Scripting. Automate debugging tasks using scripts. Time travel debugging, TTD. Record a trace of execution and replay it to analyze issues that are difficult to reproduce. 2. Setting up Windbg. 1. Installation. Windbg preview, recommended. Get it from the Microsoft Store. This is a modern version with an improved UI. It also requires the Windows SDK, Software Development Kit. Windbg, Classic included with the Windows SDK. Download the SDK from the Microsoft website. During installation, select the debugging tools for Windows component. Make sure to set the symbol path. 2. Symbol configuration. Symbols are essential for meaningful debugging. Windbg uses symbol files, PDBs, to map memory addresses to function names, variable names, and other useful information. Microsoft Symbol Server. The easiest way to get symbols is to use the Microsoft Symbol Server. Set the symbol path in Windbg. *srvc \symbols specifies a local cache directory, /symbols, where downloaded symbols will be stored. You can choose any directory you prefer. https://msdl.microsoft.com/download/symbols is the URL of the Microsoft Symbol Server. You can also use the GUI in Windbg preview to set this. Custom symbol paths. If you have symbol files for your own projects, add their paths to the symbol path. Reloading symbols. After changing the symbol path, use the .reload command to force Windbg to reload the symbols. You can use .reload/f to force a full reload. 3. Basic Windbg commands. Here's a rundown of essential Windbg commands. These are case insensitive, but it's good practice to use the standard capitalization for readability. *help displays help information. Help command for specific command help. *g, go resumes execution of the program. *bp, breakpoint sets a breakpoint. *bp address, sets a breakpoint at a specific memory address. *BP module, function, sets a breakpoint at the beginning of a function. For example, BP kernel-32, create file W. *BP address commands, executes commands when the breakpoint is hit. For example, BP kernel-32, create file W.echo hit create file W, G. *BP/1 address, one-time breakpoint, automatically removed after being hit. *BP/P process ID address, break only in the context of the specified process. *BL, breakpoint list lists all breakpoints. *BC, breakpoint clear clears a breakpoint. BC* clears all breakpoints. BC index clears the breakpoint at index, as displayed by BL. *BD, breakpoint disables a breakpoint. BD* disables all breakpoints. *B, breakpoint enables a disabled breakpoint. B** enables all disabled breakpoints. *K, stack trace displays the call stack. *K, basic stack trace. *KV, verbose stack trace, showing frame pointer omission, FPO, information. *KB, displays the first three arguments passed to each function in the stack. *KN, displays the stack without frame numbers. *KP, displays parameters passed to each function. *P, step over executes the next line of code, stepping over function calls. *T, step into executes the next line of code, stepping into function calls. *R, registers displays the values of the CPU registers. R register displays only the value of the specified register, example REX. *U, unassemble disassembles code. *U address, disassembles code at the specified address. *U function, disassembles the specified function. *U start address end address, disassembles a range of addresses. *DD, display D word displays memory as double words, 4 bytes. *DD address, displays memory starting at the specified address. *DQ, display word displays memory as quad words, 8 bytes. *DQ address, displays memory starting at the specified address. *DB, display bytes displays memory as bytes. *DB address, displays memory starting at the specified address. *DA, display ASCII string displays memory as an ASCII string. *DA address, displays the ASCII string at the specified address. *DO, display Unicode string displays memory as a Unicode string. *DO address, displays the Unicode string at the specified address. Address displays information about the memory space. Useful for finding allocated memory regions. *process switches the debugging context to a different process. .process/I process ID sets the current process. .thread switches the debugging context to a different thread. .thread/I thread ID sets the current thread. *Q, quit exits Windbg. *PEB, process environment block displays the process environment block, which contains information about the process, such as loaded modules and environment variables. *TEB, thread environment block displays the thread environment block, which contains information about the thread. 4. A simple code example. Let's create a small C++ program to demonstrate basic debugging techniques. 1. Compile the code. Compile the code using a C++ compiler, like G++ or Visual Studio. Make sure to compile with debugging information enabled. For Visual Studio, this is typically the debug configuration. For G++, use the G flag. To start Windbg *, launch Windbg. 3. Attach to the process or open the executable *. Attach to a running process *. If the program is already running, use file-attach to process or the .attach process ID command. Find the process ID using Task Manager or the task list command in the command prompt. Open an executable *. Use file-open executable and select example.exe. Debugging the example. 1. Set a breakpoint *. Let's set a breakpoint at the beginning of the add function. 2. Run the program *. Type G and press enter to run the program. The program will execute until it hits the breakpoint at the add function. 3. Examine registers and memory *. Type R to see the values of the CPU registers. Notice the values of EAX, EBX, ECX, EDX, etc., or RAX, RBX, RCX, RDX on 64-bit systems. These likely hold the arguments A and B passed to the add function. Type K to view the call stack. This will show the function that called add, which is main in this case. Use DDESP, or DDRSP on 64-bit, to display the contents of the stack. You may be able to locate the arguments A and B on the stack. Use UAdd to disassemble the add function. This shows the assembly instructions that implement the addition. 4. Step through the code *. Type P to step over the next instruction. Type T to step into the next instruction. If the next instruction is a function call, T will step into that function. 5. Examine variables *. Windbg can use symbols to access variables by name. However, it often requires a bit of coaxing, especially with optimized code. You may need to use the .frame command to select the correct stack frame. *dv displays local variables in the current scope. *dt displays the data type of a variable or expression. Variable evaluates an expression, including variables. Example. 6. Analyzing a crash, uncomment the PTR equals 42, line. If you uncomment the line that causes the null pointer dereference, the program will crash. Windbg will intercept the crash. Use the analyze-v command. This is a powerful command that analyzes the crash and tries to determine the cause. It will give you a stack trace, information about the exception, and possibly even suggestions for fixing the problem. Examine the stack trace, K, to see where the crash occurred. Look for the function that attempted to dereference the null pointer. The exception information, displayed by analyze-v, will usually tell you the type of exception, in this case, a memory access violation, and the address that was being accessed, which will be 0x0. 6. Advanced debugging techniques. 1. Conditional breakpoints *. BP address J, condition, commands, G. This sets a breakpoint that only triggers when the condition is true. If the condition is true, the commands are executed. If the condition is false, execution continues. Example, break only when x is greater than 5, assuming x is a local variable. 2. Data breakpoints, hardware breakpoints. *BA, break on access. Data breakpoints trigger when a specific memory location is read, written, or executed. They're very useful for tracking down memory corruption issues. *bar1 address, break on read of a byte at address. *baw1 address, break on write of a byte at address. *bae1 address, break on execution of a byte at address. *bar4 address, break on read of a D word at address. *baw4 address, break on write of a D word at address. Example, break when the value at address 0x0012FF40 is written to. Limitations, hardware breakpoints are limited in number, typically 4 on x86 systems. 3. Scripting ***. Windbg allows you to automate debugging tasks using scripts. Scripts can be written in a simple scripting language that is similar to Windbg commands. Create a text file, example my_script.txt, with Windbg commands. Load the script using the $command. 4. Time travel debugging, TTD, Windbg preview only. TTD allows you to record a trace of the execution of a program and then replay it forward and backward. This is extremely powerful for analyzing bugs that are difficult to reproduce. Record a trace. Use the tt.record command to start recording a trace. You'll need to specify a file to store the trace data. Analyze the trace. Open the trace file in Windbg preview. You can then use the tt commands to navigate the trace, set breakpoints, and examine the program state at any point in time. TTD requires a considerable amount of disk space, especially for long-running processes. 7. Common debugging scenarios and tips. 1. Analyzing crashes, exceptions. *Use, analyze V to get a detailed report of the crash. Examine the stack trace to see where the crash occurred. Look at the exception information to determine the type of exception and the address that was being accessed. Use, error code to get a description of a specific error code. 2. Memory leaks. Use tools like the UMDH, user mode dump heap, or G flags, global flags, to detect memory leaks. These tools can track memory allocations and identify memory that is not being freed. Use, heap stat h heap address to display statistics for a specific heap. Use, heap pa address to display the heap entry that contains the specified address. 3. Deadlocks. Use the syncblk command to display synchronization objects, mutexes, critical sections, etc. Use the locks command to display a list of threads and the locks that they are holding. Examine the stack traces of the threads involved in the deadlock to see what locks they are trying to acquire. 4. Performance issues. Use the time command to measure the execution time of a code block. Use the process ID 7 command to display CPU usage information for a specific process. Use performance monitoring tools, like the Windows Performance Analyzer, WPA, to identify performance bottlenecks. 5. Debugging kernel mode code. Kernel mode debugging requires a separate debugging machine, the debugger host, and a target machine, the debugging. Configure the target machine for kernel debugging, example using bcdedit to enable debugging over a serial port or network. Connect Windbg on the debugger host to the target machine. Use commands like process, thread, IDT, IRCL, and VM to examine the kernel state. Be extremely careful when debugging kernel mode code, as mistakes can lead to system crashes. 8. Resources. Microsoft documentation. The official Microsoft documentation for Windbg is the best source of information. Search for Windbg documentation on the Microsoft website. Debugging tools for Windows blog. The official blog for the debugging tools for Windows team contains articles, tips, and announcements. Online forums and communities. Stack Overflow and other online forums are great places to ask questions and get help from other Windbg users. Books. There are several books on Windows debugging that cover Windbg in detail. 9. Conclusion. Windbg is a powerful and versatile debugging tool that can be used to analyze a wide range of software issues. While it has a steep learning curve, mastering Windbg is an essential skill for any developer, reverse engineer, or system administrator working with Windows. This tutorial has provided a solid foundation for getting started with Windbg. Practice, experiment, and consult the resources mentioned above to further develop your debugging skills. Good luck.